members of the council, thanks for giving me the opportunity to address you this afternoon. My name is Robert Cummings. I'm a registered professional geological engineer. I hold a master's degree as well as a bachelor's from the University of Arizona in geological engineering. I've been practicing as a geological engineer for over 40 years. The majority of my current practice is in issues relating to rock excavation, and I operate as a blasting consultant, but as well as an engineer. I would mention that one of my areas of professional interest has been the execution of roadway construction projects in areas of environmental, ecological, and visual sensitivity. And this brings up the context, the concept of context-sensitive design. And when I look at the granite dells, if there was ever an application for context-sensitive design, this is it. And so what I'd like to talk to you this morning about is some of the techniques that I have used in the past that I think would be relevant to the geologic conditions on the dells. The main aspect here is the use of natural fractures when blasting new cut slopes. So this particular photograph of a spectacular example of this, where you can see that the natural fracturing system was used to form these cut slopes, is a kind of a gateway feature on the Mount Lemmon Highway, which was a multi-year roadway improvement project that I worked on between the late 1980s and the early 2000s. When I look at the granite dells, and this is an overhead that you've all seen before, as a geoprofessional, one of the things that jumps out at me is this striking fracture arrangement. All these linear features are shear zones and persistent fractures. We call them master joints. They all represent opportunities to be revealed in the future cut slopes, and they should be what controls the future cut slopes as they control the cut slopes that are in existence now. As a blasting consultant, I also look at the fact that there's very little topsoil here. This is mostly bald-headed ground, and to put a drill on these rocks will require a lot of pioneering and a lot of effort to be able to climb up there and safely execute that. So because of the fracturing estate here, it presents opportunities to replicate the existing cut slopes so as to economize on earthwork, preserve a natural appearance so that the form, line, texture, and even the color, if the rock is properly stained, blend with the natural surroundings, minimizing the footprint, minimizing the disturbance, and hopefully saving on cost. Now, I'm going to show you a picture or concept on how a conventional top-down blasting project would be done. And this may be what a lot of your constituents would be afraid of. It does not necessarily have to be this way. Top-down blasting, you have to get on top with your drilling equipment. You have to drill holes to install explosives. So you have to be able to get access to drill. And the drills have to be able to access all portions of the rock mass that need to be removed in the cut. So what this means is typically lift-wise excavation for some of these cuts. Now you can drill different and blast different slope angles. I'm going to show a 1-to-1, which is fairly simple, one horizontal to one vertical. It's a simple and common slope angle. There will, of course, be a geotechnical study that will recommend whatever the slope angle turns out to be. Whatever it is, from the cross-section I'm about to show you, I think you'll be able to see that multi-lift excavation will be necessary. And this is, I'm going to zip back real quickly. If you see that cross-section there extending from the upper left across the roadway to the lower right, this particular location is right there on the right side. That's where the cross-section was drawn from. So it's an actual cross-section from within the corridor. So what is shown on this image is its conceptual vertical dashed black lines are probably master joints because they coincide with topographic lows or shear zones. They would be features that you would want to exploit in forming the cut slopes. And it so happens that there is a master joint that catches right at the toe of this particular slope. They won't necessarily all do that, and I'll address that issue later. But you can see here that if you are able to get on top of this, you cannot drill all the way to grade in one pass. You will have to take it out in multiple lifts. Even if you were to drill all the way to grade in one pass and you blasted all that rock, it would take you a month of Sundays to clean it all up. The road's going to be blocked for an extended period of time. And you can see the volume and magnitude of the disturbance in the excavation here. On this project, there aren't a lot of rock fills. In fact, I don't think there's any. I think nearly all of this material would have to be sent to waste someplace. So that just increases the amount of ecological disturbance. Now on the right side, yes, that can be taken in one lift. Now this alternative approach I'm about to talk about leverages the use of these vertical joints, and this is an opportunity, as I say, that we have with drilling control blast holes horizontally from the roadway grade. This takes best advantage of the natural fracturing, preserves the theme, the kind of concept of intimacy, the natural appearance of the existing highway. However, it's not necessarily cheap and it's not necessarily easy. It can be done. It's been done many times before. It's within the skill set of most good blasting companies. So this is a way that you would do this alternatively. Using that one fracture that happens to catch at the toe, you drill horizontal blast holes from the roadway and you blast out what you need to, leaving a near vertical cut slope. Of course, whatever cut slope is left has to be geotechnically stable, but we've seen out there that vertical cuts are stable. If it can't be stable vertically, then you can make stepwise features using control blast holes. This is an example of doing this on the Mount Lemmon Highway. What you see on the left there is a natural slope face formed from a master joint with blast holes drilled into it horizontally. I was the blasting consultant on several phases of this project, and we probably blasted thousands of horizontal blast holes. And on the right side, you can see what this area looks like after 20 years in service. There's no extensive raveling, there's no extensive instability. The fractures are what is controlling the behavior of the slope. Now these are instances where the center line more or less parallels the fracture trends. What if it doesn't? Well, if the fractures are closely spaced, you end up with something that looks like what we have on the left here, just a fine sawtoothed kind of appearance. On the right, if you have blockier fracturing, more like what I think we would have on granite dells, you just have areas where there's a wide shoulder in some places and a narrower shoulder in others. So some would call that overbreak, but if you put it in the plans, because you know what the fractures are that you want to break to, then you have a predicted result. You planned for it. The other opportunities that you have with horizontal hole drilling is that you can replicate topographic features, such as an intercepted drainage here shown at the left. Simply by deepening the blast holes, you lay that drainage back in the same way that nature does when it cuts in between hills to form a drainage. You can warp the ends of cuts by changing the lengths of the horizontal blast holes. On the right side, you can see the problem that would have existed had horizontal blasting not been done. There's no possible way that you could get on top of that big outcrop, nor should you. That's a major topographic feature. That's a great visual interest. Makes it compelling. The Mount Lemmon Highway was a designated scenic highway. It's a recreational facility. So elements of what, and that project won a number of awards, by the way, for its the way it turned out. So that's why I wanted to bring it to your attention today. So to summarize all of this, there are opportunities here because of the geology and because of the way technology has evolved to create slopes that will be minimally invasive, natural appearing, and at the same time economical. Through either horizontal blast holes when they are necessary and drilling vertically from the top when it is necessary. But I think the industry has the capability and the flexibility to do this. I wanted to mention that when we did our horizontal blast hole drilling on Mount Lemmon, we didn't have LIDAR. We didn't have means to survey in the collars and tops of blast holes like we do now. This can more readily be done, even with drones. You could drill all these horizontal blast holes in 2 months at the beginning of the project You do have to occupy the roadway, so there would be some traffic control issues that the design and construction team would have to work out. Could be done at night. And then as you are able, you blast out the roadway in slices. I didn't want to dwell just on the aesthetics, but I think they're important for this project. We're aware that traffic control, the timing of road closures are going to be important. Control of vibrations and air blast overpressures will be important. These are, I've given a laundry list here of standard things. Fragmentation is a control because you have to be able to load the rock and haul it away. A test blast would have to be done so you can see how things are working out and how to control the vibrations and air blast. All of this is standard in the industry. There is one other aspect that doesn't appear on this slide that I wanted to mention, and that is that the city has committed to a CMAR method of procurement for this project, which means construction manager at risk. And what that does is involves the construction contractor and hopefully all of his subcontractors, including the blasting sub, at least in this case it should. In the design process, once the design has advanced beyond the conceptual stage, the contractor is engaged and the contractor's input is sought throughout the design process. So when the contract is let, there are no surprises to that contractor. He knows exactly what is going to be required and has had input in determining the constructability of the project. So we would not have a situation where we expect the contractor to come to the table prepared to do certain things that we think are important to achieve the end result and have that contractor not have put that in his bid. And then there are issues. So the CMAR method of procurement, which should be a close interweaving of the geoprofessionals, the contractor community, the public outreach people, the traffic control people, and the roadway designer, is really supportive of this entire process. So that's all that I had to say. Are there any questions?
Mayor Pro Tem.
Mr. Cummings, I just wanted to say thank you I appreciate the attention to maintaining the aesthetic, because I think that's really critical in this area, and that Mount Lemming Highway, that's certainly a worthy goal to try and achieve as we approach this project.
Thank you.
Thank you, Mr. Cummings. I was under the impression when we first started looking at this project several years ago that some of the modern techniques include some types of chemicals that can be inserted into these gaps or drill holes, and there's a rapid expansion of that chemical that causes a cleaving rather than a blasting. Is that contemplated at all in this project?
Well, this project's very much at the conceptual stage, so all options are on the table. But I can tell you what my experience with non-blasting methods of rock excavation are, especially in granite. And that is that the use of expansive grouts, which I think is what you're referring to, requires a large number of very closely spaced small blast holes. And you basically pour this solution in, and you have to keep track of the temperatures because you are looking at an exothermic reaction and an expansive reaction that forces the rock apart. And the holes have to interact with each other. So instead of drilling the holes that are shown there, you'll be drilling a whole lot more. We used expansive grouts on the Paris Dam project over in Southern California, which is out east of Los Angeles. And granite is very much like this granite. It's coarse grained, very hard. And there was a spot where, because of proximity to certain critical facilities, there was a concern that resulted in the use of expansive grouts. And I don't want to say that it didn't work, but I will say that there was a ledge of about 6 to 8 vertical feet, maybe 100 feet long, and it took a week to remove it. Because what happens with chemical grouts is that you create a fracture network, but you don't create any real dilation. So the rock then has to be peeled apart, and it comes out in chunks pretty much defined by the size of the holes that you drilled. Another possibility would be relief drilling and then using a hydraulic impact hammer, hoe ram. You wouldn't attack granite like this without relief drilling. You'd just be pecking away on it forever. I had a project in Phoenix near Pinnacle Peak where a homeowners association prohibited blasting, and the guy wanted to put in some foundations for his house. And after 6 weeks of listening to that HORAM pecking away on, and this is a residential lot, this might have been a 1,000 square foot house, the homeowners finally said, "We've had enough. What else can we do?" And we went in there with small diameter holes and we shot light charges. And after the test blast, somebody came up to me and said, "When are you going to blast?" And I said, "Well, we just did." I mean, you don't have to make something that's spectacular and belongs in the movies. In fact, you don't want to do that. That's a waste of energy and a waste of the public confidence. So, but HORAM, there's a place for it, and there's a place for expansive grouts. Maybe here and there on the project, maybe say if the toe comes out high, you don't want to blast again, something like that. But I can't see it for the amount of production that's going to be required on this project.
And it would seem like a utilization of that process would dramatically slow down the completion of the project. And with the high demand for traffic movement through that corridor, time would be of the essence to get it completed, cleared, and reopened.
Right, and that is an aspect that seems to come to the fore when the practicalities of most major rock excavation projects when those realities turn into reality, and some of those ideals get put by the side, because after a while people start getting really tired of the fact that this project is not done yet, and the escalation in costs and what have you. So,
any other questions or concerns? Councilwoman Cantelmi?
Thank you, Mayor. Thank you for the presentation. I just had an additional question. As you enter past the roundabout at Watson Lake, probably about a half a mile, and I'm guessing, there's a stacked rock formation that we call it monkey ears. I don't know what it's actually called. But what happens in a case like that where they're just stacked? Do you just move them aside, or how is that treated?
well, if you can't avoid it, by relocating the road around it, and obviously it has to be removed. And it depends on how it's stacked. I was the geological engineer and blasting consultant on the new US 89A bridge over Marble Canyon, and we had some of the bridge features that needed to be removed that were stacked rocks like that. In that case, we had this deep canyon, and we just drilled horizontal holes into the base and blasted out the foundation, and it all fell down into the river and was lost. In a case that's above ground like this, there's some ways that you can do it. You can get on top with a crane basket and have the guys hand drill holes and shoot small charges and break it down. If the individual pieces of rock are small enough, it's conceivable you could put anchors in it and pull down the sections individually. A lot of times people wonder about the stability of features like that if left in place in the vicinity of blasting. And the kind of blasting that we're talking about here would, by necessity, use relatively small charges. It's amazing how natural rock formations, are tolerant of ground vibrations. They just don't act like houses do. So I hope that answers your question.
Yes, thank you very much.
Yeah.
Well, thank you, Mr. Cummings. We appreciate your long experience and expertise, and it's comforting to know that a lot of this work can be done with minimal public concern. We won't eliminate all of it, but
My pleasure.
being able to move forward and complete a project of this scope and size, I think, is certainly important to really move forward. When we look at those vehicle numbers and capacity, we really have to move forward on this. And the longer we wait, the more difficult and more impactful traffic and potential accidents and fatalities and injuries are likely to occur. Thank you very much.
Yeah.